Hey everyone, and welcome back to Math. How are you doing today? Well, last time we looked at further perspectives on negative numbers. In particular, we saw that a negative number could be thought of either as subtraction or as multiplication, and how both of those kind of have different flavors or perspectives on what it means to actually be a negative number. So we're going to get comfortable with those ideas with these questions I've prepared for you today. So go ahead, pause the video. I have them all written here, and take a shot at them. Assuming you've done that, let's go through them together now. Alright, so number 1. Express the following negative numbers as subtraction. So we have negative 12 as our first one. So what is negative 12 as subtraction? Well, subtraction is moving to the left of 0. So this perspective, we're thinking about negative 12 as being 12 to the left of 0. But moving to the left of 0 is the same as subtracting from 0, right? So we have 0 minus 12 is the same way to think about negative 12. All right, now we have negative 4.1. I've thrown in a decimal here. That shouldn't trip you up, though, because it's the exact same thing as before, right? This is a number created equally as that one, right? Negative 4.1 is just as real and deserves just as many rights as negative 12. So we can do this in the exact same way, right? Thinking about negative 4.1 as being a shifting to the left of 0. So that is 0 minus 4.1. And you're a master at this by now, I'm sure, but negative 0.001, that is the same thing as 0 minus 0.001. And just as a little review, do you remember what this place is called from your math classes in school? Well, this is the tenths place, hundredths place, so this has to be the thousandths place. So that's a little review for you. All right, moving on to number 2. Express the following negative numbers as multiplication. So in part 1, we saw them as subtraction, which is where we think of a negative as being basically a shifting from 0 to the left. But we can also think of negative numbers as multiplication by negative 1, where if we have a number line, if we want to think of negative 3, we can start at 3 and then flip the number line, and we see that 3 will line up with negative 3. So we can think of multiplying by negative 1 as basically applying the negative to this number line, and hence we can express negative numbers as multiplication by negative 1. Another reason for this is that a positive times a negative is a negative, right? So exploiting this, we can write negative 13 as being just 13 times negative 1, which is basically saying, hey, we have 13 and we are flipping it, which gives us negative 13. Moving on, we have this crazy number, but just like negative 4.1, it is created equally and deserves all of our love and attention and respect. So we have a negative 2.123,123. Fun little pattern going on in there. So what is this written as a product? Well, we just take the number 2.123123 and we multiply it by negative 1, right? Because this is taking the positive version of the number and then flipping it, which brings us to the negative version of it, the reflected version of it, right? All right, and then lastly, this one's a little bit weird, negative 1. Well, we were always looking at these numbers as being something times negative 1. Well, in this case, it would have to be just positive 1 times negative 1, since we're starting at 1, and if we reflect that, we flip it over 0, we get back to negative 1, right? But another way we can think of this is, what's something times 1? Well, it's just itself, right? 3 times 1 is 3. 5 times 1 is 5. 1,002 times 1 is 1,002, right? So we can also think of this as being, well, what's negative 1 times 1? It's got to be just itself, so negative 1. But in any case, these are the answers to number 2. Man, we're just flying through these. All right, for number 3, we got some word problems now, some applications of these ideas to show you where this kind of thinking actually could be useful. I ran 50 kilometers going south. How can we express this distance as a negative number? All right, so let's start with that part. So 50 kilometers going south, and we want to express this distance, right? Kilometers, that's a distance, as a negative number. Well, if we want to think of going south as negative, that means going north is positive, right? So if I draw a line here, And I know I'm committing a sin by not using a ruler, but that's all right. So we have 0 at the very middle, and this is the north direction, this is the south direction. And if we're considering north to be positive, that means south will be negative. And over here, we are considering negative 50 kilometers. Right? And we can have other numbers in between, but really we just want to see, okay, how do we think of this as a negative number? It's 50 kilometers, but it's south, so we're putting a negative on it. Whereas 50 kilometers north would look something like this, where it's positive, since we've defined north to be our positive direction. All right, now it's saying, is it better to think of this as 0 minus 50 or 50 times negative 1? Well, what makes more sense? Moving 50 to the left of 0, that's 0 minus 50 perspective, or starting at 50 and flipping it over 0 to get to negative 1. That's the multiplication perspective. Well, let's think about the problem. It says I ran 50 kilometers going south. So if I ran 50 kilometers, which means I started here, right, and I went in this direction, that type of movement is just a sliding over, right? There's no reflection happening. This is kind of irrelevant over here. So if we're thinking of this kind of movement, then subtraction is the better way to think of negative 50 in this case as being 0 minus 50, where I start at 0 and then I move 50 to the left, which we know is what subtraction does. All right, awesome. Moving on to number 4. All right, so this one says, I got permanent marker on a page in my notebook, and you can see the marking on both sides of the page. All right, so I'm going to take out a notebook here. This was from one of the math classes I took when I was an undergrad. Really good class, and maybe someday we'll cover it on the channel. It's pretty advanced, but in any case, we're going to take a page from here, right? Let's go with this page. And it says the question says that we applied some permanent marker to it. Okay, so I'm going to take a permanent marker here. Well, it's a whiteboard marker, but same thing. All right, and I'm going to get a nice mark going right there. All right, and when we flip the page, yeah, we can see that there is still a marking on either side because the marker has seeped through, right? And let's look at the question again. It says the marking is 20 centimeters from the center of the notebook. All right, so let's just assume that this is the center of the notebook and it's saying that this right here is 20 centimeters long. Whether or not that's the case, I'm not sure. Oh, it's actually pretty close. If that's the middle, there's 20. Yeah, so that was pretty good estimate. All right. In any case, it says the marking is 20 centimeters from the center of the page, and we start with it on the right-hand side. So just like it is right here, it is on the right-hand side, but when we flip the page, oh, it's kind of off there, but yeah, you can see it's moved to the left-hand side, right? So it's saying that how can we express where the marking is using a negative number after we flip the page? So if we think of the page right here, this is like position 1. If this is 0 and this is 20 centimeters, this is like positive 20. But when we flip the page, now it's like the marking is at negative 20, right? If this is 0 and this was positive 20, now this is at negative 20. And the question's asking, is it better to think of this as 0 minus 20 or 20 times negative 1? Well, if it's 0 minus 20, we're thinking like the dot started at 0 and it moved over here. But is that what happened? No, that's not what happened. What really happened is that the dot was over here and we flipped it over, right? So what models this flipping action better? Subtraction or multiplication by negative 1? Multiplication by negative 1, right? So if we look at this question, is it better to think of the negative 20 in this case as being 0 minus 20 or 20 times negative 1? It's going to have to be 20 times negative 1 because we were flipping it back and forth. All right, awesome. So let's look at question 5. So this one says a standard NBA basketball court is 94 feet long. All right, so this one's for you basketball fans out there. How many feet does it take to go from one end of the court to the middle? So we have our basketball court here. And it's saying, hey, this is 94 feet long. And this is like the middle of our court. You got like your circle there, and you got like your ends of the court here. We want to know how many feet from one end of the court to the middle. Well, if the whole court is 94 feet, and we're considering from one end to the middle of the court, what portion of the court is this? It's half the court, right? We're basically dividing this court into two pieces. So what this is considering is it's 94 feet divided by 2, right? Because there's two sides of the court that we're splitting this into. And when we do that, what do we get? Here's a little review in long division. 94 divided by 2, we're saying, okay, 2 goes into 9 how many times? Well, 2 times 4 is 8, so that's pretty good. We subtract off the 8, and we get 1. Bringing down the 4, we get 14. How many times does 2 go into 14? 7. So 7 times 2 is 14. Subtract that off, we get 0. So 94 divided by 2 is 47 feet. And hopefully this was a review for you. If not, maybe take some time and go over that. Just look up long division online and you should be able to find a lot of stuff on that. I would consider that to be prerequisite material for what we're doing. In any case, we have the answer to part A, that the distance from the end to the middle is 47 feet. Alright, so Sarah and Sasha are going to have a race to see who can get to the middle of the court faster. Sarah is at one end of the court, so let's put Sarah over here. Yeah, that's Sarah. And Sasha is still in the middle of the court, it says, right? So Sasha is still in the middle of the court. So Sasha's right here. Which means that she has to get to the end of her court first for the race to start, right? So they want to see who can run to the middle the fastest. Sarah's already over here, but Sasha's being a bit lazy. She's still in the middle. She's got to get over here in order for the race to even begin, right? So if we consider the middle of the court to be 0, so we're saying, hey, this middle right here is 0, and Sarah's starting point to be our answer from part A, well, our answer from part A was 47, so it's saying that over here has to be 47, right? So you see we're kind of making a number line out of this, right? Then what is Sasha's starting position? Well, we want Sasha to be over here, right? And if Sasha's over here, and it's the same distance from 0 to one end as it is to the other end, then this has to be negative 47, right? Because the distance is the same, it's just a different direction, right? That's the standard idea of what a negative is, right? It's just the same value, but in a different direction from 0. So Sasha's starting position is also 47 feet from 0. It's just in the opposite direction as where Sarah is, which is why we've put them on different ends of the number line. All right, awesome. So that was part B, and then part C. If we want to think of Sasha moving to her end of the court using subtraction, how would I do it? So Sasha's starting here, and she's moving to this end of the court. How are we going to think about that using subtraction? So we know that she's going to be at negative 47 feet over here. Now we have two ways of expressing this. We have multiplication and we have subtraction. This one says if we want to think of her moving to the end of the court using subtraction, how would we do it? Well, negative 47, that is the same thing as 0 minus 47, right? So that's how we would express this, but what does this mean physically? Well, this is meaning Sasha is moving from 0, 47 feet that way, right? So we can express this negative 47, which is where she's ended up, as basically being her starting at 0 and moving 47 feet to the left, right? In her direction. All right, and then part D, if we want to think of Sasha moving to her end of the court using multiplication now, not subtraction anymore, how would I do it? So we're thinking about negative 47, and that expressed using multiplication can be written as 47 times a negative 1. So what does that mean, right? We can't really think of that in terms of subtraction anymore where she's moving to the left because that's what part C was about. But for part D, this is multiplication by a negative. Well, what does that represent? That represents kind of starting at 47 and then flipping, right? This multiplication by negative 1 is basically like applying a negative, which will flip our position. So we're kind of thinking about Sarah's position, which is 47, right? Being flipped to over here. So what this kind of represents is basically Sasha's position is the reflection of what Sarah's position is, right? In order for it to be a fair race, they need to be the same distance from the middle of the court, right? So thinking about negative 47 as the reflection in this way is basically saying, hey, this distance for Sarah is the same for Sasha. We're just kind of reflecting that to be in Sasha's direction. So those are two different ways that we can think about Sasha's movement over here. Either by her just moving to the left from the middle, or by her moving to a place that basically reflects where Sarah's starting position is, right? Just in the opposite direction. Well, I hope you found those examples illuminating, and you should have plenty of practice at this point. We're getting pretty close to being done with kind of this review on different perspectives of arithmetic. After 1 or 2 more videos, we're going to be getting into a review on fractions and taking a good deep look at those. But in any case, that's going to do it for me today. Have a good one, stay groovy, and I'll see you in the next video.